Hi everyone, I'm Natalie with the Santa Cruz Museum of Natural History. Today, I'm going to show you how to do a quick activity that'll help you explore nature. Have you ever been in a forest? In fact, have you ever been inside different types of forests? Have you ever noticed the differences between different types of forests, like the different plants and animals that only live in one type of forest or another? Today, we're going to scientifically measure one of the key things that contribute to those differences in forests: canopy cover. In a forest, a canopy is all of the plant life that is above ground, like all of the leaves above us. And canopy cover refers to how much of the sky is blocked by the tree canopy. Now it's time to make our tool to measure canopy cover. This cool tool is called a basic densiometer. To make our densiometer, we're going to need three things. 1, a small mirror. 2, a marker, either dry or wet erase. And 3, a ruler. What we're going to do is make a grid on your mirror. Use the ruler to draw dots that are equally distant from one another, about 1 centimeter. It's important that you count how many dots you end up having, because we're going to calculate canopy cover based on those dots. As for me, I have 24 dots, so I've written the number 24 on the corner of my mirror. And congratulations! You have just made your own basic densiometer. You'll also want our canopy cover worksheet, which is linked right below this video. Or if you don't have a printer, you can make your own. For that, you'll need a pencil and paper. Now let's test it outside. For a control, measure the canopy cover right outside of your home. This is what the outside of my house looks like. There are some trees, but right above me, I've got a clear sky. Looking at my densiometer, not a single dot is covered up by tree leaves. That means 0 out of 24 dots means I have 0% canopy cover here. A good scientist takes lots of data, so I'm going to do the same reading close by, about 5 feet off, 2 more times. Still no dots covered, so we are still at 0 out of 24 makes 0% canopy cover outside of my house. How does yours compare? Now let's go to a forest. The forest I'm stopping at is a mixture of oak and pine trees. Some oak trees don't lose their leaves but are a special type of evergreen different than conifer trees. Using my densiometer, I can see there's a good amount of canopy cover here. Do the same thing at your forest and write down the number of dots covered by the tree foliage. Just like before, take multiple sets of data, both at the same and at different locations, to get even more accurate readings. Also, take a look at all of the plants on the floor, or the underbrush. Here, I'm seeing a good mixture of ferns, as well as some California blackberry, and, well, it is poison oak season, I guess, so I better be careful not to touch that. Write down what plants you find at your forest. If you don't know their names, that's okay. You can write down a description or even draw what you see. Now see if you can find a forest with different types of trees, like a redwood forest. How is this forest different than the first one you went to? Do you think it will have more or less canopy cover? And, based on both the canopy cover and the underbrush, do you think the amount of canopy cover affects the plants that live on the ground? Form a hypothesis. Write it down, and let's see what data we get here. Wow, this redwood forest is really different than the oak woodland I was at before. I can tell just by looking that there is more canopy cover, and the underbrush is different. I'm going to write down the plants that are here, and I'm also going to note if these plants were or weren't also at the oak forest. Now, it's time to get some data. Once you've gotten a good number of readings, it's time to compare the forests. For that, you're going to take an average. At my oak woodland, I had about, on average, 50% of my dots covered up. At my redwood forest, I had an average of about 75% canopy cover. What was your hypothesis? Remember the different underbrushes that you saw? How does your data support your hypothesis? And, based on your data, what is your conclusion? Thanks for doing a science activity with me. I can't wait to hear how yours went. Again, this is Natalie, and I hope to see you sometime at the Santa Cruz Museum of Natural History.